Okay, so here we go with this one. So functions f, g, and h are twice differentiable functions with g of 2 equaling h of 2 equaling 4. The line y equals 4 plus 2/3 x minus 2 is tangent to both the graphs of g at x equals 2 and the graph of h at x equals 2. Okay, so first let me say twice differentiable. This is meaning they're telling you here we've got a continuous and smooth curve. Actually, differentiable would have been enough to tell you that it was continuous and smooth. Twice differentiable means that the derivative is also differentiable and smooth because you could take the derivative twice. So, yeah, okay. Now, the first thing they want us to find is h prime of 2. All right, so h prime of 2. And if you look, this is the equation of the tangent line to both the graphs of g and h at 2. So, guys, so if I wanted to use, like how does h prime of 2, how does that fit into this? Well, we've got our equation of the tangent line formula. So this is really h of 2 plus h prime of 2 x minus 2. And then you just look for, what lines up with h prime of 2. And actually, Logan, you were the one who pointed that out to us. So we get that h prime of 2 is 2/3. Okay. Now this second one, let a be the function given by this. Write an expression for a prime of x and then find a prime of 2. So guys, we're going to need to use the product rule. All right, so this is part B. So this is going to be a prime of x equals 9x squared, bring down h of x, plus bring down 3x to the third, h prime of x. Okay, now I will plug in 2. So this is going to be 9 times 4, h of 2, plus 3 times 8, h prime of 2. This is 36, and then h of 2 is 4. They already told us that. That's 24. H prime of 2 I found is 2/3. Yeah, so 36 times 4, what is that? That's 120 and 24. So that's 144, I think. 144 plus 16. Yeah. All right, I'm sorry. I know this is not a calculator, but I just don't want to be doing it wrong. Plus 24 Yep, 160. Okay. Now part C. Okay, this is, so everybody, I know you guys can pick up points on A and B for sure. And I think you can on C and D also, but this is where it starts to get a little bit challenging. So the function h satisfies this, okay, for x not equal to 2. All right, so what there's, yeah. All right, so for x not equal to 2. So guys, this is like only a representation of h for all x's that are not equal to 2. H exists at 2. Like the actual function h does exist at 2 because h of 2 is 4. This function here, I guess they're telling you that it does not exist at 2. Yeah, so that must mean, that it's undefined. So it's definitely undefined at 2. And yeah, but h is equivalent to this for all other values except for 2, okay? It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show the work that leads to your answers. Okay, so now this is part C. Okay, so, guys, if you're going to use L'Hopital's rule, okay, if you are going to use L'Hopital's rule, the very first thing that you do is you do direct substitution, and then you either get 0 over 0 or infinity over infinity. So I'm going to do a direct substitution with the limit of this, and then I'm going to see, and then I'm going to set it equal to 0 over 0. And you'll see why 0 over 0 and not infinity over infinity. But guys, also, the fact that we're dealing with the limit as x approaches 2 of h of x, we actually know what this is. We actually know what this number is, because f, g, and h are twice differentiable, which means that they are continuous. And for a continuous function, the limit as x approaches a certain value is equal to the very function at that value. Okay, so I'm going to say, okay, since h is continuous, all right, and I'm just writing it like this for our notes. Since h is continuous, and I know it's continuous because of this twice differentiable. All right, they're not asking me to explain anything here, so I'm not explaining that. But if they asked me to explain, I'd have to say h is continuous because it's twice differentiable. Okay, so since h is continuous, the limit as x approaches 2 of h of x is equal to h of 2. Guys, that is the third condition of continuity. It says that you can evaluate a limit by doing direct substitution. And what is h of 2? It's 4. Okay, so boom. So we've got this information off the bat. Now let's see how L'Hopital's comes in. Okay, so the limit as x approaches 2 of x squared minus 4 over 1 minus f of x to the third, okay, equals, wait. All right, so the first step of L'Hopital's rule is you plug 2 in. If you plug 2 in the top, you're getting 0. If you plug 2 in the bottom, you get 1 minus f of 2 to the third. But guys, if they're telling you it is known that this can be evaluated using L'Hopital's rule, it's got to be 0 over 0 or infinity over infinity. Now look at this. So this means that 1 minus f of 2 to the third equals 0. That bottom has to equal 0. So this means that f of 2 equals 1. Right? F of 2 equals 1. Now we're going to find f prime of 2. So the first step in L'Hopital's rule is you show direct substitution, you get 0 over 0, infinity over infinity. But then what do? Then you go, therefore, by L'Hopital's rule, all right, so I'll be like, by L'Hopital's rule, this is equal to the limit as x approaches 2. You take the derivative of the top over the derivative of the bottom. So the derivative of the top is 2x. Now the derivative of the bottom, derivative of 1 is 0. Now the derivative of this, you're going to need chain rule. So the derivative of the inside here is f prime of x. And the derivative of the outside is negative 3 blank squared. And then f of x goes back in. And then you do direct substitution again. So the top is 4, the bottom is f prime of 2 times negative 3 f of 2 squared. We already found f of 2, that's 1. So this is 4 over negative 3 f prime of 2. Now, guys, I was actually having a hard time when I tried this problem because I had it up to here, but then I was like, whoa, I can't solve for f prime of 2 unless I set this equal to something. And then I was racking my brain. I couldn't figure out what could I set that equal to. And that's where this comes in. That's why I wrote this at the beginning. I didn't realize this till like later in the problem. Since h is continuous, we know that the limit is the same as the function value, which is 4. They told us at the beginning. So this is 4 over negative 3 f prime of 2. That's got to equal 4. Or you could put it over 1. If you cross multiply, you end up getting negative 12 f prime of 2 equals 4, right? 4 equals, yeah? And then, so you get f prime of 2 is negative 1/3. Okay, this is a long problem, but this is something you could do. You can do it. With enough training for sure. Okay, now part D. It is known that g of x is less than or equal to h of x for x between 1 and 3. Let k be a function satisfying this. Okay, g is less than or equal to k is less than or equal to h for x's between 1 and 3. Is k continuous at x equals 2? Justify your answer. Now, guys, I gave you, so if you haven't already, you should pause the video and like look at the page above this one in the document where this is, because I give you preliminary information. I review what it means for a function to be continuous, and then I talk about something called the squeeze theorem for limits. Okay, so I'm not going to really discuss those. I'm not going to go into depth too much right now with those, so make sure you look at that, okay? All right, so this is what we're trying to do now. Okay, so guys, you've got to ask yourself, is k continuous at x equals 2? Well, what would that mean? K is continuous at x equals 2. There's 3 conditions of continuity, but it's really the third condition, and I actually talked to Mr. Crockett about this. The third condition does imply the first 2 conditions, okay? Sometimes, depending on the situation you're in, sometimes the first 2 conditions are more helpful to solving a problem. But if you're in a situation like this where you've just got to answer this question, is k continuous at x equals 2? It's better to just say this: to show continuity, we need the limit as x approaches 2 of k of x to equal k of 2. All right, that's what we would need. This alone would imply continuity, okay? Because this alone implies like that the limit exists and the function value is defined. Alrighty, so now I want to be considering this right here. All right, so let me think about k of 2. Can I figure out what k of 2 is? All right, and it is asking you to justify your answer. So let me be very clear with my logic. All right, so since g of 2 equals h of 2 equals 4, and g of x is less than or equal to k of x, which is less than or equal to h of x, g of 2 is less than or equal to k of 2 is less than or equal to h of 2. So 4 is less than or equal to k of 2 is less than or equal to 4. So we've got k of 2 equals 4. Okay, so that's going to help us. Do you need to show every step that I did? No. I really think you could go right from, I think you could just like go right from from these to that. All right, for sure. Yeah, the person who's, I looked at somebody else's answer key and they didn't show all that detail. Okay. Okay, so, all right, so I know that K of 2 is 4. So if I can show that this limit is also 4, then I've got continuity, all right? If I can show that this limit is something other than 4, then I could say it's not continuous. All right, so now I'm going to use the squeeze theorem. So, all right, if I knew the limits of g, if I knew the limit as x approaches 2 of g of x, and the limit as x approaches 2 of h of x, and those limits were the same, then I could say that this limit was also the same. So look at the notes that I provided above this problem for that explanation. So let me think about the limit of g and h. I actually already brought in the limit as x approaches 2 of h. So since g and h are continuous, we have, okay, and I'll be like, because they're differentiable. Okay, we have the limit as x approaches 2 of g of x equals g of 2. All right, that's the condition of continuity. But then g of 2 is 4. They already told us that. And the limit as x approaches 2 of h of x equals h of 2. That's because of continuity equals 4. Therefore, since g of x is less than or equal to k of x is less than or equal to h of x, we have the limit as x approaches 2 of k of x equals 4. This is called the squeeze theorem, okay? If these two limits are 4, this one's going to be squeezed in between them. So the limit as x approaches 2 of this one is also going to be 4. But guys, what is 4? 4 is k of 2. All right, this is what we wanted to show, is that they both equal 4. I'll be like, therefore, the limit as x approaches 2 of k of x equals k of 2. So k of x is continuous at x equals 2. Okay,